Hello everyone, my name is Maurice Barnett, and today I would like to share with you my final project for CPSC 4820 Machine Learning. I tried to apply machine learning to something that I enjoyed growing up, which would be Pokemon. If you are unfamiliar with Pokemon, a Pokemon is just a fictional creature with types and stats. There are 18 total types a Pokemon can be, and a Pokemon can be multiple types. These types include water, electric, and even flying. There are 6 stats that a Pokemon has. These stats are HP, attack, defense, special attack, special defense, and speed. The question that I seek to answer today is there a way we can correlate Pokemon types to their stats? In order to get data for this problem, I used a website called Kaggle. Kaggle provides a bunch of data sets that can be used for machine learning and data science. I found that there was one that was just about Pokemon, specifically generations 1 through 6. The information for this dataset was also sourced from PokemonDB and Bulbapedia. The dataset consists of the ID for a Pokemon, their name, their type, and their stat information, along with which generation they were and their legendary status. Now, before we do any calculating, I needed to figure out how to represent my input and my output. I needed to represent my input somehow, so I made an array of 1s and 0s the size of 19. This accounts for the base index, which always stores the value 1, and an index for each type, which would store 1 if the value was represented in that Pokemon or 0 otherwise. To represent the output, I needed to separate my work into 6 different calculations, one for each stat, so that I'm only using one output value in each calculation. This output value was normalized relative to the total stat number of that Pokemon to give a percentage. This is to remove bias from legendary Pokemon, higher evolution Pokemon, or just generally stronger Pokemon. This percentage was then multiplied by the amount of types that the Pokemon represented. This is so that each type is represented equally. For the actual calculation of the weights, I simply used the normal equation algorithm that was used in the first project. Now that the input and output was sorted out, I needed to split the data into a training set, validation set, and a testing set. The training set used 600 of the 800 total data points and was used to calculate weights and a cost value. The validation set was used to calculate another cost value, and the testing set was used to calculate a final cost value with an adjusted R-squared value. From the chart, we can see that the cost fluctuated a good bit depending on the set and the stat, showing that there was not a very strong correlation. This can be further seen by the relatively low R-squared values that showed moderate correlation in attack and special attack, but pretty weak correlation in HP and speed. Even though the correlation does seem to be pretty weak, the interesting thing is that we can still see trends in the data. While the original intent of this project was to feed in a type or two and get the 6 stats that would correlate to that Pokemon, I think the far more interesting result is shown in the general trends that can be seen in the weights. On the screen you can see 2 charts, and these charts just contain the same weight values but are colored differently. We can see on the left which stats a type is good for relative to itself, which would be itself being the type. This shows things such as rock, bug, and steel being relatively good at defense, whereas the elemental types of fire, water, grass, electric, and psychic are relatively strong in special attack. The chart on the right shows how good a Pokemon is in a stat relative to other types. This shows traits that each type is generally known for. For instance, rock being strong in defense yet very slow, or electric Pokemon having a strong special attack and being very speedy. It really shows the balance that each type has something it's relatively good and relatively bad at, sometimes multiple things. And these strengths and weaknesses are spread out across the board when comparing who's good at what versus other types, which gave me a very pleasing conclusion to this project that I'm very happy that I undertook. Thank you.